Okay, this is the SURF Project Paleontological Training presented by Pacific Paleontology, Wayne Thompson. Project location, of course, is in Monterey Bay, southern Monterey Bay. Monterey Bay, below the surface of the ocean, is dynamic and has shaped the landforms and the fossils and paleontology of the project corridor. We're going to take a look at the geological layers underneath the project um, and take a look at what they are. For the most part, they are Ice Age, but there is also a bedrock layer that is um, quite important as well. Um, there's a few different marine terraces out here, and we're going to be going through what those are in just a second. All right, here's the geology underneath the bay, and here's the geology section of the project right in here. This is the Salinas Valley right over here, this long area. And Monterey, of course, downtown Monterey down here, and the project is in this area right here, and you can see the different geological layers of Ice Age material. Getting a little closer and deeper into what the project is about, here's the southern terminus of the project out at Playa Avenue. Seaside High is right here. We had quite a discovery of fossils right in this area. We'll talk a little bit more about those. Here's the marine terraces that are present out along the corridor. We'll talk a little bit more about those too in more detail. Another map showing the entire project right here. A little closer view. Here's another map yet showing the details of the older dunes, the marine terraces, and we did find an artificial fill right here that was pretty interesting. We'll talk more about that as well in just a second. Here's Sand City. Here is the sensitivity rating for the southern project area. Excluding the current project excludes this Custom House Plaza area. So going from the Playa site all the way up to Marina and the Palm Avenue site, it is rated as low to high with increasing depth of grading. Low to high sensitivity, paleontological sensitivity, with low being low priority and high being high priority, basically. Here's a little bit closer view showing the geological layers. The ones to look out for, geological layers, the important ones are the older coastal dunes. These are in the Ice Age per se. Floodplain deposits, Ice Age fossils have been found in floodplain deposits in the past, as well as this older ocean view coastal terrace. That's an important one. Artificial fill, these sections right here, this is right there at Playa. Those are made up of rock brought in for filling during construction of the railroad. And lastly, this lighthouse coastal terrace. These two coastal terraces are important paleontologically. And there's a little bit another view of that, a little bit more geography. All right, well, these coastal terraces are really interesting because they formed during the last ice age by the rising and falling of sea level and the rising and falling of the land surface relative to that sea level via plate tectonics and mountain building forces. Basically, what they've done, what has happened is that the geography of our coast is carved by ocean wave erosion processes into a staircase. This is especially up in This is called an ecological staircase, especially up in places like um, north of San Francisco, where this forms an ecological gradient. But what we're concerned about is the paleontology of these various steps, as they're called. So older terrace, usually right, right here, uh, and getting older and older and older and older as you go up. And this is mirrored also by a submarine set of terraces below the ocean surface. Here's a cartoon view of what these look like. They're composed of a marine terrace right here, the WCP, and a cliff that accompanies it. So here's the step and a cliff, the older cliff here being eroded. Here's another view showing the processes that happen, tectonic uplift, as well as the combined effect of rising and lowering of sea level during the Ice Age that is mediated by global temperature changes, which itself is moderated by celestial events, the eccentricity of the Earth's orbit and the tilt of the Earth's axis have changed global temperatures over time, such that the absolute height of the ocean has changed up to 300 feet in the last several thousand, 100,000 years, so that we get mammoths, for instance, that can walk out to the Channel Islands because sea level was 300 feet lower. Pretty fascinating. And here's a diagram. It seems complex, but I'll explain it. Basically, these older drops in sea level. There's 3 older drops in sea level right here that were significant, and so these really carved into the landscape, the staircases and steps, and strand lines as they're called. And here's the below submarine staircase right here, and showing the subsidence of the land as well as the increasing height of the ocean waters. All right, so right here's Seaside High for perspective. This is the Playa site where we found quite a few fossils, and this is a borehole location that will become important in just a second here. Here's a map showing several of the fossils that we found. There were hundreds of 9 million year old fossil clams out here, but this was a fill site, and so the sensitivity of that is lowered because of that. Even though there are fossils here, the sensitivity was low because it's a fill site, and we are uncertain about where those fossils originated from. And so here's the culvert. The Playa site is up here, and this culvert and canyon are all composed of fill material. Even though these sands here are Ice Age, the fossils themselves are 9 million years old from the Monterey Formation bedrock that's present underneath all of these Ice Age sediments here. Here's the details of the boreholes showing that there were exogenous material down here, asphalt and things like that, down deep, up to 10 feet deep. So it was definitely a fill site. Here's the Palm site. We also found fossils at this site here. Um, they again they were Monterey Formation, older, which is 9 million years, um, embedded in Ice Age sands. So probably a fill from a site nearby. There's a specific location of where the fossils were found. We'll show you some pictures of those in just a minute. And here's Beach Range Road site where we found uh, the, the the third example of these older fossils. There it is, plotted on the map. And the fourth site where we found fossils is out of the staging area. We found 9 million-year-old fish fossils here in these two locations. And again, these were embedded in Ice Age sediments that were disturbed. And so sensitivity is low here. There's a little bit, another photo showing the Fifth Avenue site and boundaries. There again, there's where we found the fossils. Okay, please bear with us here that we're going to talk about some of the laws and regulations. Project personnel have an obligation to protect and preserve scientifically and socially valuable paleontological resources. Violation of these laws presented above is subject to federal, state, and local felony and misdemeanor prosecution under the laws. Penalties for violation of federal, state, and local regulations is punishable by civil and criminal felony, misdemeanor, and misdemeanor penalties, including fines and or imprisonment, and could result in the revocation of project certification. So fairly significant. The California Coastal Act has mandates for paleontological resources where development would adversely impact archaeological or paleontological resources. Reasonable mitigation measures shall be required. California Coastal Act in part authorizes the California Coastal Commission to review permit applications for development within coastal zone where necessary to require reasonable mitigation measures to offset the effects of that development. The other regulation in California is the California Public Resources Code, which states that no person shall knowingly or willfully excavate upon or remove, destroy, injure, or deface any prehistoric or vertebrate paleontological site, including fossilized footprints or any other paleontological feature situated on public lands, except where they express permission of the public agency having jurisdiction over those lands. And violation of this section is a misdemeanor. California Environmental Quality Act is the main overarching act that is guiding mitigation of paleontological resources here in California. And they are explicitly afforded protection by CEQA. Under CEQA, the treatment of paleontological resources is usually conducted in accordance with guidance from the Society of Vertebrate Paleontology, which administers the details of how this law is rolled out. The Omnibus Public Lands Act, Paleontological Resources Preservation, recognizes that there are uniform criminal and civil penalties, uniform resource use permits, uniform definitions for paleontological resources, and uniform requirements for curation of federal fossils on approved repositories. Federal legislation protections for scientifically significant fossils for projects that take place as well. The Paleontological Resource Preservation Act of 2022 is the most recent and most comprehensive paleontological protections, and it's based on NEPA of 1969, the National Environmental Policy Act. In basic terms, with the passage of the Paleontological Resources Preservation Act, paleontological resources are considered to be a significant resource and it is therefore now standard practice to include paleontological resources in NEPA studies in all instances where there is a possible impact. Well, let's talk a little bit about what is potentially can be discovered out in the project corridor. As I mentioned previously, the rock layers there have been known to produce a plethora of different ice age creatures, land mammals for the most part, giant land mammals. Starting out with mammoths. So we know in our area that Columbian mammoths used to live here, and they're preserved in the rocks of the coastal terraces. Here's a beautiful reconstruction by Mark Markison of a herd of Columbian mammoths. So here's what a Columbian mammoth tooth looks like. These teeth are giant. This one up here is about a foot long. These were grazers, and so they occupy the ecological niche of a cow or horse. And these teeth are designed for grazing and processing huge amounts of grass every day. And so this is what the teeth look like. Notice the shape, the color, the texture. If you see anything that looks like this, you're probably looking at a mammoth tooth. And we'll get to what should be done if you do find something like this in just a second. There's another view of another mammoth tooth showing color difference. This is what a mammoth tusk looks like after it's just been hit by a earth-moving equipment. Notice in particular here the sediments. These are lake or river sediments here, and this is from a discovery out nearby the project here in Castroville. These sediments can be diagnostic. So if you see sediments that look like this, look the color, the fine texture, and that could potentially be a lake or river deposit. A little bit closer up, showing what ivory looks like if it's broken, and another tusk. Well, also in our area, we have other kinds of elephant-like creatures. This is a mastodon, Pacific mastodon, Mammoth pacificus, and it's not a mammoth, and it lived in a completely different environment most of the time. It was a browser, and it lived. It spent most of its day along rivers, stripping leaves from trees, predominantly alders. They loved alders, and it's one of my favorite creatures of all time, hence our logo. The Pacific mastodon was first discovered in our area in 1980 in Santa Cruz County, and since then there have been other discoveries. These are the teeth of a mastodon. They're completely different from mammoths. These are browsing teeth that are used for a different purpose. And so this is from a specimen on exhibit at the Santa Cruz Museum. So these creatures are also present in our area. This is what a bone looks like if it's been broken. Pay special attention to the texture and the shape of these canals here. These are marrow canals, and if you see anything that looks like this, we'll talk about what to do in just a second. A little bit closer up view of some of these lake and river sediments that are on top of the terraces that we talked about earlier. Well, in the last 2 years, we've added a couple other creatures to our ongoing list of Ice Age fauna here in our area. The first one is this one right here. This is Megalonyx Jefferson's ground sloth, and it is called Jefferson's ground sloth because TJ, Thomas Jefferson, our former president, was the first one to find one and describe it. He actually brought the the bones of the one that he was describing and found to him to accept the presidency um, back back in the day, and um, uh, quite an interesting story. So it's called Megalonyx jeffersoni because Thomas Jefferson was the first person to find it. Also, in the last few months, actually, this fellow has surfaced in our area, Paramylodon. And Paramylodon was another ground sloth, about the same size as Megalonyx, and it was it's added to our list also. These ground sloths were giant. They're about the size of a modern day bison, same size, same weight, um, and just like the name says, they lived on the ground, not in the trees, like a sloth you would think of today. This one, by the way, was quite interesting. These guys, Megatherium, made burrows up to 8 feet in diameter. They were burrowing ground sloths. Real cool creatures, not found in our area. Here's a skeleton of one of these extinct giant ground sloths on exhibit at the LA County Museum. Okay, let's talk about um, some of the other fossils found in our area. These are um, these holes right here in the rock. This is a sediment-filled hole. This white-colored rock is the older 9 million-year-old rock that's present deep down underneath the project corridor. And these holes were made by drilling clams that drilled down into the solidified 9 million-year-old rock during the Ice Age. So these are Ice Age fossils drilled into a rock that is 9 million years old. And this rock is actually an organic sedimentary rock. It's made up of millions of diatoms, which are a they photosynthesize. They're kind of like plants in the ocean. They're part of the plankton that floats around on the top of the ocean. There's another picture. Both of these fossils are found locally and are potentially found underneath our project. Well, let's talk a little bit more about the older fossils that come from down underneath the project corridor. This is the Monterey Formation, about 9 million years old. Here are some of the fossils that were found out in the Surf Project corridor at the Playa site. These are Sophidia clams. These are deep water clams that used to live 9 million years ago, deep under the ocean when the ocean was several thousand feet. The ocean surface was several thousand feet above where it is today at Playa. And so these were found out on the site, and they came from the area of fill. So they're not from that exact location, but they're suspected to be originally from somewhere fairly nearby because other fossils of this nature have been found nearby. There's another fossil, spectacular fossil, that was discovered at the Playa site. This is a scale of a type of sardine or mackerel fish scale. Again, this is 9 million years old from the older layers. Here's yet another example of the preliminary work on the Surf Project site. This is a piece of the Monterey Formation, and it has these drillings of Ice Age clams in it, these circles right here. That's what that is. So that's another fossil found during the initial surveying of the Surf Project. Well, let's talk about other fossils that potentially could be found. There's a number of different types of fish that are found, of course, scales, bones, and whatnot, teeth. So this is a fossil fish from the same layer, same Monterey Formation layer out in Carmel Valley. Parasitic crabs that live inside clams. These are pretty cool. More parasitic crabs there. Clams, various types of clams. There's some more clams. And pectins. Beautiful, beautiful pectins. Dyskineska, it's kind of like a clam. Okay, so what to do if you find a fossil or a suspected fossil? If you find a suspected fossil during construction, construction workers shall immediately halt construction within 50 feet of any potential fossil find and notify the supervisor, project manager, and project paleontologist Wayne Thompson at Pacific Paleontology. There's my number, 831-535-8545. And all of that evaluated significance. Failure to report suspected fossils is a violation of federal, state, and local regulation and punishable by civil, criminal, felony, and misdemeanor penalties, including fines and/or imprisonment. Halt all work in the area. You don't have to rope it off, but just make sure that it gets a 50-foot buffer. Contact site supervisor and myself. There's my number again. Don't try to move or relocate the specimen. If you find it, leave it exactly where it is. Information will be lost if it's moved, usually, and breakage may occur if it's moved as well. There again, there's my contact information. There's my phone number, and there you have it. Okay, this has been a presentation by Pacific Paleontology of Santa Cruz and Monterey, Wayne Thompson. Over and out for now.